Uh, I'm Sean from the NANOG Program Committee, and I'm going to turn this over to Gabe Cole from the RTE Group and OpenIX to present our other speakers and kick off the track. Thank you, Gabe.
Thank you, Sean. Good morning, everyone. Nice way to start the day today. As Sean said, I'm Gabe Cole. I'm the Executive Director of the OpenIX Association, which sets standards around data centers and exchanges, and I'm also a principal of RTE Group, which is a consulting firm that does data center siting, data center strategy for both service providers and enterprises. So we're going to kick off with a presentation by John Hawkins of vXchnge. If any of you are not familiar with vXchnge, John will give a little bit of background on himself and the company before he starts his presentation. But vXchnge is basically the second coming of switch and data facilities. Most of the senior management, we're the senior management of switch and data, so they're giving it another try in the industry. And then I will make a presentation on some of the nitty-gritty details of data center design and procurement. And we're going to have a panel discussion with John, myself, and we're going to add in Phill Lawson-Shanks from EdgeConnex, as well as Craig Weick from CME, the Chicago Mercantile Exchange. Their co-location group. So should be a good time. Think about any questions you might want to ask us as a collective group. We'll stop between each presentation for some questions as well, and then I'll wrap up the very end with a very brief update on OpenIX. But with no further ado, let me introduce John Hawkins of vXchnge.
All right, thank you very much. Appreciate it, Gabe. All right, good morning, everyone. I hope you all are enjoying this wonderful San Diego weather. I came from Portland, Oregon, where it was about 45 degrees and raining, so this is a big shift for me, and I do appreciate it. Before I get started, I just want to thank everyone for coming today. I know that there's a lot of priorities, and there's things that we have to do, but making time for these networking events is important. And also, thank you for NANOG, and the executive sponsor who made all of this possible. So I think it's just a great opportunity. So as Gabe did say, we are switching data 2.0, I guess you can say. From that perspective, what we really are about is we're providing a data center as a service. So if you think about the construct of a telephone and what your phone looked like 30 years ago, when it had the rotary dial on it, and you had a cord that came off the back, and there was party lines, and you had to, make a call, and if your sister was on the phone, you couldn't get the phone, and someone tripped over the phone cord. So that's what we're trying to do for the data center, and what we're trying to do is get us to a point where we have an iPhone or an intelligent phone, so that the data center is going to be software defined, as opposed to something that is just made up of facilities. It's made up of all of the components that make the data center. So those are a couple of the real exciting things that we're looking towards, is being software defined, providing data center as a service. So I'll give you a little brief background about myself. I've been consulting for a little over 20 years now. I had an interesting career. For the first 10 or 15 years of my career, I was very technical. So I actually was a Java developer. I've written code. I wrote a book on Java, and that was where I thought I would be. And so along comes cloud and something, the shiny object, and I decided to kind of go that direction. So for about the last 8 to 10 years, I've been in the cloud space, and I've been helping large organizations build their strategies for cloud. I've been helping to do organizational change and helping make sure that those data center solutions that we recommend all align with what an organization is trying to do. So from that perspective, let's get started. So application architectures, cost of doing business. Gartner says that only 6% of companies survive longer than 2 years after they lose their data. the future. Right now, we're looking at the mobile device expansion, the Internet of Things, and data predictions are looking to go from, what was it, up to 44 however many bytes. There was an interesting article on Cisco, on a Cisco website, that said that in the current state, in 2013 to 15, all the data that we have, if you stacked it on iPads, would stack 2/3 of the way to the moon, right? In 2020, they're saying that that will not be 2/3 of the way to the moon, but that iPad stack would be 6.5 times stacked to the moon. So what does that mean for us? That means for us that data is going to be key in the future, but what is common across every data transaction that we have? It's the network. And the networks are something that are really going to be key to us in the future state. And that's one of the reasons why I'm so excited about what we're doing. So today what I want to talk about is how do you go about assessing the risk, right? So my background is technology, but I also understand strategy. So what I'd like to go through is the data center strategy and 7 key points that I feel if we address these, we can help make better sound business decisions with our organizations. So at the center of it, though, is the data center strategy. It's how do we assess the risk, identify our needs, what is our location, the redundancy that we have, our best practices, ongoing maintenance, and ultimately planning your disaster. So when I think about businesses fail for a lot of different reasons, and there's a lot of different businesses out there. So I'm going to give you a couple of examples, because when I look at the numbers that are out there, it's hard for me to make a comparison as to how much money people are losing. So when I was out doing consulting, I had a small, it was a dating company, but basically, their idea of cost of business was $2,000 an hour. And I said, well, how do you come up with that number? And they said, oh, well, when we do a marketing campaign, we lose, we spent $2,000, per minute to do that. Okay, that's one data point. Second company was a large trading company, and they would trade large volumes of shares. So they would go trade 100 million shares at one time of stock. And if there's latency and there's a little bit of time in between the transaction, these pennies add up pretty quickly. And then the third example was a large company that did mortgages and banking, and their estimation was that they lost $100,000 for every minute of downtime. And they had a 5-hour downtime, and they called me in and said, John, we just lost $150 million of revenue that we cannot bring back because of that outage. Also with, there's a lot of SLAs that have to be met and other things that all add up to us having challenges with, the business. So from that perspective, when I look at a company, I look at their business goal. The capabilities are their enablers, which are the technical components that make up the data center. And then also the people, process, and tool, because this really is an orchestration that we need to have. Gabe, my pictures aren't showing up. What's that? No. So I apologize, we don't have the pictures up here. So one of the ways that we do this, though, from an organizational perspective to try and come up with a strategy is you've got to get all the key stakeholders involved. So it starts at the senior level management, and it goes all the way through down to the lower levels, which is the communications network, which if you flip it or invert it, you think really everybody has to go through that communications layer. So if you take that and you were to take and bisect a data center, and from that data center perspective, you bisected it, you have all these different services that stack up on top of each other. So at the bottom, you've got your carriers, you go up through the raised floor, you go up through the racks, you go up through, to the servers, you've got infrastructure as a service, you have software as a service, platform as a service. So really, to be able to provide a strategy for an organization, you have to take into account the business needs, but also involve all those stakeholders. So one of the fundamental tenets that I like to think about when looking at a data center strategy is what are those different groups or different kinds of folks that we have who might need to consume these services. So I'll give you an example here. We've got the micro data center and co-location. Co-location, we all know what it was, but there's a new way of thinking about co-location, and that's really the data center as a service. And those guys really focus on the micro data center. They engage a little bit with network services and do some with communications. But from that perspective, that is one type of unit of work or customer that we can try and satisfy. The second are the edgers, the Internet of Things, right? As we start to create all these smart devices that are out there in the universe that are providing data, how will that impact the network that we have today? Do we need to save all of that data? Is that data transient data? Is it something that needs to be saved? Right? Those are things that we're thinking about and have to adapt from a business perspective. The Red Bull startups. I love the Red Bull startups because they're really focused on products. They don't need technical services. They don't need an ecosystem. They want to go out there and build the next software as a service or platform as a service. We've got the Amazonians. So these are the guys who are looking at hybrid, trusted, and private cloud. Now, if you notice, I put Amazonians up here with the CEO, line of business, and administrator, and I did that for a very specific reason. It's because when you look at it, it's the business making the decision on who should be consuming cloud services. However, if we go back and we look at edgers and Internet of Things, those might not be the business owners and stakeholders who are driving those. What this means is that the data centers that we're seeing that are being built, in remote regions of the country, they're one paradigm, they're one solution, but there's other needs out there from a customer perspective. So what we're trying to do is look at all those various needs. And then finally, there's also the enterprise. So the enterprise is one of the most demanding of the customers because not only are they thinking about how can we do Internet of Things, but we're looking at cloud strategy. We might want to do some startups, and we also might want to be on the edge to provide our services. So from that perspective, I just start to think about what are the solution that we're trying to provide to our consumer stakeholder. So from a takeaways perspective, okay, we're going to do a quick break here. You guys are not able to see any of the pictures that I borrowed from the internet.
You can keep talking.
Okay.
So your pictures. Good?
That's perfect. All right, sorry about that little technical hiccup there. That was the Internet of Things, or the Internet gremlins, I think, taking my pictures and doing something with them. So from that perspective, the solution really drives what we're trying to do and hopefully your data center strategy. And if I go back, you see that I've kind of associated these personas with each of those folks that represent there, from the CEO to the architect to Aaron. And one thing that I like to do is really put a face to that person so that when you're thinking about that customer solution, it really makes it real for you, and you start to think about what is it that they would want, not what do I want to give them. All right. So the takeaways are really, what is the business objective? What problem statement or solution pattern are we solving for? What is the feasibility of the solution? Is this within our core competency? And then when we define the strategy, are we aligned to all those stakeholders? So if we decide that we're going to go after those Red Bull startups, what would that data center paradigm look like? If we're Amazonians and we're looking to provide those types of services, what would that? Are we looking at hybrid cloud, or are we looking at some other solution? The next thing is identify your needs. So it's very important to really understand from a data center perspective, what are the needs? Are you looking at co-location, or are you looking at other types of data center services? So from that perspective, here's the kind of the data center value pyramid that I put together. And when I think about data centers, I think about it from a perspective of what's the customer's business goal? Are they edge? Are they looking to build their own data center? Are they looking to deploy in days, not months? Are they looking for solutions for enterprise startups or e-commerce? What is that? Then there's this whole concept of data center as a service. I mentioned we're trying to provide data center as a service. That, I think, is where data centers need to go. It's where you, as a consumer, can sign up and consume data center as a service, and then those services are provided to you. And it's based on what you need as a consumer and that solution group that you were looking at. Then there's a lot of different capabilities that data centers have. You've got micro data centers, multi-site data centers. There's the whole risk management, the governance. Are you in single site or multi-site? So a big trend now really is to have edge data centers. It's having those, because what happens is performance causes latency, or distance causes latency. So the greater the distance you are from your data, the bigger the problem for your consumers. So there's a big trend for large content providers to put their solutions inside of these edge data centers, and we're seeing a lot of that. And then what are the enablers? So your MOPS and SOCs, your power cooling, do you need 24/7 support? So what are all those capabilities that are going to help from a process perspective to meet that end goal? Location. So location can be a big factor. Are you in a floodplain? Are you in an area that gets hurricanes or other natural disasters that potentially could impact? So from that perspective, location, I think about, do we need to be on the edge or not? Do we need to have our site staff to be able to access the data center? We know that there's a big trend for putting cloud providers putting their data centers in these big regions in the center of the country or centrally located. But is that the best solution based on the need that we have and the business needs from their perspective? And then is the data center in a floodplain? If it's in a 100-year floodplain, a 500-year floodplain, or completely outside? Now, if you answer yes to all these questions, that doesn't necessarily mean it's a bad data center for you or a bad place to build. You just need to look at how you're going to be using that data center and make sure that it aligns to that strategy. Redundancy. So redundancy, if you have one component fail, there's a system that's online to take up the load for you. So how important is redundancy to the strategy? So if you have a data center and you have redundant generators, but you don't put diesel fuel into the generators, is the redundancy any good? So it's not just having the redundancy in place, but it's having the people, process, and tools to be able to do that. The application redundancy, in many cases, there's applications, and you can program the application so that it handles transactions, right? Are these transactions idempotent? Do you have to be able to pick up the transaction? Do you need to be able to provide content out to these other edge sites so that your consumers have the ability to consume those content services? So that's the application redundancy. We also see some customers who are just clustering their hardware inside of the data center. So now they've got clusters of redundant servers within the data center as opposed to trying to have full redundancy all the way through. So there's a number of components that go into that. So whenever you're looking at your data center strategy, does that align to what you're trying to do? Data center process. So one of the things that we think is extremely important is making sure that we have repeatable process within our data centers. And the way we do that is that we hire people who know what failure means. What I mean by that is that we hire the guys who run nuclear submarines to come in and do our data centers. Because if you fail when you're below the ocean floor, there's a good chance that people will die. So we take those, when you build your data center and you have your process, your MOPS and SOCs, it's extremely important to think about what are all those data center process that we should be thinking about. So from that perspective, some of the strategies and takeaways you can do is that people are the biggest cause of failure in the data center. You want to check your process to ensure that the risks are mitigated. What are those checks? Are you doing the integrated system testing? So we do individual unit tests, but have we done it as a whole group, each individual system? Are we doing our cross-connect testing? Are we looking at our infrastructure testing and infrared testing and predictive testing? And hire people who understand what downtime means. You can have a beautiful new data center, but if you don't have the right people in it, it's not going to be there when you need it. Ongoing maintenance. Maintenance is important. Right here I've got a picture of what diesel fuel looks like after it's been sitting for a while. And then there's a process called fuel polishing, where you take out the water and you clean it. So now you have clean diesel fuel. So I know that I was not part of all the war stories of the guys who have been through these situations, but a couple of stories were interesting to me. One of them was of the hurricanes that happened in Florida. And there was a big outage, and the data centers went down, and a couple of the generators didn't kick on. And they didn't kick on because the fuel was not clean. So fortunately, the guys who were telling the story, they were the heroes of the story, and their data center did have clean fuel. But it's one of those little nuances that you have to think about. In addition to that, from a design perspective, the generators were on the roof, and they didn't have electricity to push the fuel up to the roof. So it means that we had to have people redundancy, where they found out a way to be resilient and take 5-gallon buckets of diesel fuel up so many flights of stairs and fill the diesel generators with fuel. So those are the kinds of things that you want to be thinking about and doing from a maintenance perspective. So always ask about your maintenance procedures and programs. Are people afraid to do maintenance because human touching the equipment can cause problems? That's a possibility, right? Review the mops and socks to ensure there's concurrent maintenance. Make sure that the facility staffs are involved in those data centers. If they have a vendor come in and do the maintenance on their systems, right, that vendor has to manage 100 or so units, but with that individual site manager, they have one data center and 1 or 2 generators to maintain. They don't have a bunch, so they should be involved. And get to know site staff by name, because when you do run into a problem, you never know when they're going to be able to help you. And finally, from a planning your disaster recovery perspective, it's very important to start thinking about what's going to happen when we do have a disaster. We learned a lot about this after Sandy, when that came through. And the challenge was that it wasn't just the data center that needed to run, but it's the people who were in the data center. And these are people like you and I who have families, who want to go home, but they need to be able to have certain creature comforts so that they can continue to do their job. So from that perspective, we learned that we need to plan our disaster recovery around the people as well. It's not just. So how do we do that? We provide food, water, showers, a place for them to be able to go and clean up so that they can continue the work that they have to do. Whether or not you're building your own or not, it's very important to start to think about the people and who it is that is going to be ultimately in that data center when you do have that outage, so that they can work effectively. So from that perspective, really making sure that we have a concrete strategy in place. It's all about having those business goals, the capabilities, making sure that we've got the right people, process, and tools, and that we've got that alignment all the way from the CEO of the company down to the guy who has to, put the fuel in the diesel tank. And then from that perspective, here's some tips that you can start thinking about from a data center strategy perspective, so that as you come up to making decisions about data centers, there's some ideas for you to think about. So that's all I had. Do we have any questions? Okay. Thank you.
Thank you, John. And the people aspect is really important. I did have the chance to see the new vXchnge facility in Philadelphia, and it's very interesting to me how much space there was dedicated to people and support. There's not just configuration rooms, but there's offices, there's showers, there's all of those things, and that's that was a big trade-off back in the day when many of us started in the co-location business. You wanted it all to be data center, and you didn't really take time and put stuff in for people. So but Sandy and the other hurricanes really taught us the importance of that, and not just for that, but just for setup and day-to-day operations. What I'd like to do now is take a step back and say, okay, you've got the charge to go get a data center. What do you need to think about? How do you need to work that process and and define what you need and build the internal support and teams that you need to achieve a data center that's going to meet all your needs? Typically, there's three big things that if you're charged with building a data center that you need to worry about. One is cost. You want to do it as economically as possible. Even though reliability is important, the bottom line cost is always going to be the hurdle. I see almost no users of data centers, whether financial services, whether media, whether service providers, that are insensitive to cost. So getting that in place is very important. Improving delivery, and there's a lot of aspects to that. That's moving to the next generation of services. That's making your existing services more efficient. It's improving problems you may have with existing services. A new data center is all about doing that. And then last but not least, it's about risk management. You're going to build this new data center. You're putting yourself out there. It's a big thing for the company, for the enterprise, and if it fails, it's not good job security for you. So getting it right, getting everybody to understand where the risks are and how those risks are mitigated is critical. So, what are the details there? How do you make that happen? We're firm believers that you reduce costs through a competitive process. You can also reduce costs through your energy efficiency and also your network interconnection. And there's a lot of aspects to that. It's the cross connects within the data center itself, but it can also be the cost of getting the network to that data center if it doesn't have a network. How do you improve delivery? You have to look at where your data is going, the path that it's going, and find locations that optimize that move it from the data storage to the compute to the end users as quickly and efficiently as possible. And you manage the risk through the selection process, through contract structure, and through governance. A lot of people think, well, they go out, they get a data center contract, that's the end, that's the beginning. That's the beginning of the relationship and managing that relationship and managing that contract moving forward. So what are the key factors to decide around a data center? There's what market you're going to put it in and the search process that you're going to build around that. There's what do you need in terms of space, power, low voltage planning in terms of interconnection of networks and what networks do you need. There's the whole process of network in the facility, how you turn that up and manage that. There's the management of the build itself. The build out of a data center is pretty complicated. People think turnkey data center, it's ready to go. There's a big difference between when you buy a turnkey data center that's there and fully built out and ready for cabinets versus when you go into a co-location facility and you buy your cabinet. There's a lot of stuff that you've got to select the cabinets, you've got to select the low voltage conveyance systems, the cabling. It's all got to be built, coordinated together. Sometimes even that requires a building permit. So there's a design process that goes up ahead of it. So there's a lot to actually fitting up the data center. There's systems integration. The data center itself is going to have systems, whether they're BMS, building management systems, or DCIM, data center information management systems. There's these base systems. Are you going to tie those to your enterprise systems or to your service provider NOC? Very important questions to analyze and to ask up front, because if that's important for you to have NOC integration, and a provider absolutely cannot provide that or doesn't have the ability to provide APIs to support that, there's no real sense burning cycles looking at their data center. Change control, problem resolution. How are you going to interact going on between the IT and the higher level operations and the data center itself in terms of making sure you have the right service windows, making sure that you're minimizing those risk components. And then what's the duration here? You know, what type of lease are you entering into? How long is it going to last? What's the administration? That's actually a big deal in the enterprise segment right now, because most enterprises, when they look out forward, they feel that their data centers are going to shrink over time, that progressively, not necessarily quickly, but progressively, they're going to move more and more things into the cloud. We all know the cloud needs a place to live, but nevertheless, from the enterprise perspective, they see that their needs are going to shrink. So they're looking for alternatives to locking in a data center for a long period of time. They're looking for the ability to shrink, whereas other customers, service providers, and the cloud providers are looking for just the opposite, the ability to progressively grow in the same location without having to take on a huge commitment from day one. So getting those factors right and aligned with the organization are really critical. Critical power infrastructure. When you're looking at a data center, oftentimes data centers don't want to show you their one-line diagram, and they probably won't give it to you to look at. But the single most important component when assessing a data center is to understand every aspect of that one-line diagram and how the basic design of power systems is constructed. So even if they won't show it to you, you need to take time to sit down with them to find the person either in the facility or in their operations group that understands that and can walk you through step by step how the systems work from the utility all the way down to your cabinet. And so that you can understand in different failure scenarios, utility failure, UPS failure, generator failure to start, you can understand what the implications of each of those things are and be able to translate that into your risk profile and how well you need to deal with it. You need to understand when you're looking at that one-line diagram what any single points of failure are. And just as important as single points of failure, what the repair sequence and timing is behind that. So I've seen many facilities where there are single utility transformers that they're very unlikely to fail, but they have failed. And in some cases when they failed, it's taken 2 or 3 months to get a replacement transformer. That's a very long time to be on generator backup. And in fact, it's too long. The generator just will not run for that period of time in most cases. So in that case, you're looking at scenarios where you're bringing in additional generators on trailers, and you're getting into very complex switching to keep the data center moving. So understanding that repair sequence and that timing and behind any points of failure is really critical. And finally, just around the critical power infrastructure, what is the quality of the design, the procurement, the maintenance? And by what I mean there, and you've got to balance this, but obviously if you're buying from a manufacturer that's made it for 20 years and it's been proven and it's fully maintained by that manufacturer, that's very different than buying something that's from a manufacturer that's only been in business for 3 or 4 years and maybe doesn't have a fully baked out maintenance organization and just doesn't have that track record. I'm not saying there's anything wrong with that second category, because that second category is where we do things that are innovative, we save a lot of energy and everything else. But going back to keeping your job, it's important that everybody in your organization understand that you've gone into that second territory and what the risks are, and it just may not be as reliable as the data center that they were used to buying from the name brand that's been in business for 20 years. So just important to understand and communicate all of those aspects of design, equipment that's being used, and how it's being maintained. One thing we're starting to think about a lot in the data center is increasing voltage, and increasing it at many different locations. Higher voltage requires less copper to move it around, and so that makes the infrastructure much more efficient. It makes space usage much more efficient. So particularly if you're doing something in a high-rise, multi-story scenario, going to higher voltages allows you to deliver much more power to the data center in less space. So what does that mean? That means on the service side, medium voltage above 2500, 4160, sometimes as much as 25,000 volts. Much higher voltages than we've seen before to take it from the utility to the main switch gear to the UPSs. The advantages: you don't have any conversion loss. You don't have any heat produced from the conversion loss. You have much better power stability. Every time you put power through a transformer and change the voltage, you create some instabilities, and you have fewer points of failure. The disadvantages: the UPSs and generators haven't quite caught up yet, so it's harder to get them in those higher voltages. The maintenance people are not as used to dealing with the higher voltages for generator and UPS. So we're seeing hybrid designs where it might be 4160 or 25,000 and all the utility infrastructure down to unit substations serving a pod, and then it goes back to 480 volt, and the generators and the UPSs are 480 volt. But I expect that will change in the next few years, and we'll see more higher voltage going all the way through, including UPS and generator. Same thing's happening on the other side. So 15 years ago, we put 120 volt circuits into cabinets, and then we went to 208, and then we went to 208 three-phase. Well, probably many of you have put in boxes that a 208 three-phase 60 amp doesn't support. So what do? You put in two. And so that starts to become very inefficient. Each one of those PDU strips costs, $1,000, $1,200. So if you're putting in 4 instead of 2 or 6 instead of 2, starts to run up your cost, also starts to use up your real estate, so it becomes very hard to manage. So how do we solve that problem? We go up the next level. We go to 480 volt, three-phase, all the way to the cabinet. That's getting to be pretty serious power, so you need to be careful and you need to design it properly, and there's a lot of implications to it. But again, particularly in higher density, higher power, that's a trend we're seeing, and in order to deliver that density in the most efficient way with the fewest losses, the fewest components that can break, and the best efficiency in terms of delivery. PUE, the PUE challenge, power utilization efficiency. As a general rule, everybody does it differently. There is no set definition of it. And because of the intricacies of design and operation, they can be very different. And that can have a big impact on your operational costs, particularly in a multi-user facility, because many PUE calculations, particularly ones that are used to recover cost, are averaging the cooling cost over multiple users. So even if you've made your equipment more efficient from an energy perspective, it's still, you're getting a penalty on the cooling side. It's also very hard to find incentives and to align those incentives. So for a data center operator to incent a user to use less power, it's just not really there. So what do you need to do there? As a user of the data center, you need to build a model, you need to validate that, and then use that as an ongoing tool to work with that data center to monitor the usage, to monitor the efficiency, and to make it as efficient as possible. You also need to structure the contractual side of that, the lease or the license, to achieve that as well, to get the maximum benefit of energy savings. So again, very, very important aspects of what we want to accomplish in the data center design. Expense structure. This is where it gets into fundamental real estate, and there can be a lot of tricks played. So you need to understand whether you're dealing with a net rent or a gross rent. We all hear the $150 a kW or $125 a kW or $115 a kW. The problem is that somewhere when it gets down to around $115 a kW, it may actually be that as a gross rent, but it's probably a net rent. And as you go through the contract, you're going to learn that you're going to get another bill that's going to be $15 or $25 or $35 a kW. That's your tax and your operating expense. They've just taken a page out of the old real estate handbook and they've decided to package their rent differently. So you really need to understand how your rent is being calculated, and when you're comparing different facilities, you need to make sure that that's a true apples to apples comparison, that you've grossed up all the rents and you have all that cost structure in there. It takes a close analysis of their lease, of their standards, of how they calculate their bills. I oftentimes ask for model builds so that I can see exactly how they're going to build it up and bill for the space, so that we can tie everything back together and use that as a guide. How is power cost recovered? Is it metered? Where is it metered? Very important to understand that and to understand the efficiency associated with that, because different metering locations can have different effectiveness and they can have different averaging involved in them. So you need to understand that. You need to understand, as I said before, how the cooling recovery is done. A lot of people just want to put a round number on it. I'm going to charge you twice as much as you use for power to take care of cooling and everything else. I'm going to charge you 1.5 times. Again, that doesn't give you any incentive moving forward. So you want to work with your provider to be able to understand how cooling is calculated, understand how power is calculated, and then really to tie that together into what is our long-term strategy. You know, we're going to be together here for 5 years, for 10 years in this data center. We need to learn how to save power over that period of time. How are we going to be incented to do that together? And last but not least, the last important thing to model and communicate internally in your organization is what are the additional operating costs. Are you going to have to hire people to be on call to go out to that data center if they don't have remote hands, or you don't have confidence in the remote hands? Are you going to have to assign more staff hours to monitoring and managing that data center than you have in the past? So understanding those internal costs and the chargeback implications of that are sometimes as important or more important than understanding what the pure external costs you're getting from a data center provider are. Project schedule. You know, how do you pull this together? And I've shown it kind of overlap because a lot of projects get overlap. But you know, when we talk about a base building of a data center, that can be anywhere from 6 months to 2 years. It's 6 months if it's part of a campus that's already been permitted, that maybe the shell is even up, that you know, they don't have to go through an entire permitting process. It's 2 years or maybe 3 years if you're going to Poland to build one, where you have to go through land use approvals, you have to go through utility approvals, you have to go through a whole bunch of hoops before you can even start thinking about putting a shovel in the ground and building a data center. And yes, there are some places in the U.S. that are that difficult too, that go to those two boundaries. So, you know, understanding that and then running through the process, putting out an RFP, using that to then select and build a letter of intent, get the lease done, the base building work, the commissioning. Those are all the components that have to be done before you even start layering your data center on top of that. And then you have the data center fit-up components. That can be any place from, you know, a month to maybe 3 months, depending upon, again, whether you have to have it permitted, designed. That's the low voltage design itself, any long lead time items. You know, don't assume that if you're putting in, you know, 128 strands of fiber that you can go buy that at the local electrical supply. It might be a 3-month order to get that big of fiber. So, you know, understand all the components that are going in, lead times, and get those orders in place. A lot of times, the low voltage design, putting in the cabinets, the racking, the fiber, the cross connects, you can lose a lot of money there because a lot of, particularly if you buy it directly from the data center, they have no real incentive to save. You've already signed a lease with them. You're already there. You're captive. You're really kind of handing your wallet to them if you let them do it. So you want to make sure that there's a competitive process. Whether you jump in and do that competitive process or whether you force it on your data center provider to do a competitive process on your behalf, you would be amazed at the spread I've seen. I've seen spread of, you know, 2x in just getting 3 bids on low voltage design to put in cabinets overhead racks and fiber cross connects those components. It's all a function of how busy they are, how badly they need the work, are they doing other work in the building or nearby. It's just incredible how big the difference can be. So that competitive bidding is really important. And then monitoring the installation process, making sure that, again, either the data center provider or you have someone that's there as your owner's representative that's monitoring that work and seeing it going in. And then comes the turn-up. That's when you get to turn it into a data center. So that's when you turn up your network. Again, there may be long lead time items on network. There may be need to build additional network out there in the world. So, when I look at data centers, I'm always, kind of interested to see how when you pull down a fiber provider's fiber build, there's these big loops, and so the data center's on the loop. Great. Well, if you then go and say, well, I need 12 fibers, they're like, well, I've got this section over there that I built with somebody else, and I don't have 12 fibers left on it. So I'm going to have to go back out. Maybe I have to permit it. Maybe I have to go through a process. I can give you 6 fibers to begin with, but it's going to take me 7 or 8 months to get those other fibers built and give them to you. So important to tease those things out early in the process and get that in place. And you have your rack and stack, you have your turn-up, and you have your operations. And that turn-up needs to be closely correlated with the original commissioning that was done as part of the base building build-out, so that that everything matches up and you don't have any issues there, as does the intermediate build as well. So as I said, network detail is very important. Just to build on John's point, as we move forward, the network is the cloud, the network is the data center. There are data centers behind it, obviously, that provide the space for the equipment, the space for the data, but the network is really the key component and makes or breaks pretty much everything from this point out. So when you're looking at a data center, you need to understand who the available providers are, what that topology is. Not just is there enough fiber along those legs like I just talked about, but are there legs that are collapsed? Are there legs where even if you go to, you buy a loop from a single network, or even if you go to multiple networks, that they're not in separate alignments, that there is one shovel that could come down and dig up everything. Again, you'd be amazed how often that happens, and how often that happens even with some very significant telco hotel buildings, if you don't really drive the network providers and work with them to make sure you have that diversity at every point, diversity from the cabinet to the meet me room to the entries into the building and every place out in the world until it gets to your other point or points on your network. Is there a meet me room in the building, or are you doing direct network into your space, or is it a mixture of both? In today's world, with high capacity, high fiber services, dark fiber services, very important to have the right to take that all the way from the street to your space. Not to go through a meet me room, not to go through a carrier room. Increasingly, we see that as a big requirement, and increasingly we see data centers able to meet that requirement. Even the modern meet me room today is not like it used to be. You don't see a lot of optical equipment in there. You don't see, it's basically a fiber patch room. Carriers bring in fiber, they patch that directly through to the customers, and then they deliver whatever services they need to over that. The access to dark fiber is really important, and with sufficient quantity and competitive pressure. Now in the DC market, we see tenants in that market that are buying hundreds of pairs of fiber and using that sometimes in lieu of DWDM gear in order to get some resilience that they don't feel they get with the DWDM gear. So dark fiber is here to stay and is becoming much more important. Lit services and value-added services, just important to understand what those are, to understand if it's got a good mix there. Can you buy IP transit if you need IP transit? Or are you going to have to do a tail for 7 miles to some other location? Big difference in cost. So, those are the things to really, it's what you guys do every day, but those are the things to be thinking about. Layout and design. It's not just a data center, so it really starts with the cabinets, understanding what the cabinets are, how those are going to be laid out row to row, how you're going to do hot aisle, cold aisle, how you're going to do your spacing. Are you going to use hot aisle containment? Or are you going to use cold aisle containment? There's advantages and disadvantages to both. And sometimes there's advantages and disadvantages based on what your equipment kit is. Sometimes it's just based on which side you need the most access to for people and where you want them to be, the most comfortable. So very important to work through those details and to have the full layout of what you're doing. It's an example of a layout here, both the plan layout and the cross-section layout. And in this case, that became very important because this was an area where we had to have it permitted. So we actually ended up having to go in and move fire sprinklers to align and lights to align with the aisles to meet this, and in fact even had to drop some fire sprinklers down beneath the trays because this particular jurisdiction was very concerned about the potential for any fires in the trays and the conveyance even though we were using plenum rated cable. So really important to get that design, get the sign-off from everybody in your organization that's going to be using it, and get the sign-off from the data center owner and get the sign-off from the municipality. Cabinet's not a cabinet. This is a sample of a cabinet order. So, and this is a situation where there might be many different cabinets in the same build. So you've got different types, you've got different tops, you've got different widths, heights. You've got different layouts, so really important to get this all worked out for a couple of reasons. First, you're going to want to bid the cabinets competitively with that low voltage, so you want a full kit together of what you need, and you also want commitments to the unit prices for the cabinets as part of your initial procurement. So if you do miss anything, when you go back and buy it, you're getting it at the price you negotiated, not 10 times the price you negotiated. So really important to do this sort of detailed analysis and build around, what's going into the data center up front. Same thing on PDUs, those units that go into the cabinets. They're not all the same either. There's many different varieties there. There's many different layouts. And most of you probably don't know this, but most of the big PDU manufacturers, the rack PDU manufacturers, or MOA as it's called here, multiple outlet appliance, they'll actually custom build those. So if you have a particular configuration that you're not getting the right count of plugs and you're going to go out and build 50 or 100 of those, they'll build custom PDUs for you, and they will even go through the UL certification process for that, for numbers that are on that scale. So really important to understand that, to get that right so that your people, when they rack and stack, have the plugs they need and aren't having to use converters, aren't having to tie things together or jury rig things. Just very important and speeds up the process greatly. There's also a lot of differences in terms of whether those plug in or whether those are directly wired into whips. Increasingly, we're going to see them directly wired into whips because it A, saves money, and B, reduces some of the fire code issues relative to underfloor. So it eliminates some of the requirements for underfloor fire protection. So we'll continue to see some movement and some changes there. So that's basically it. Happy to answer any questions as the panel comes up. We need to grab one chair there, and then we're going to switch to panel mode.
What's the threshold cabinet density to justify 480?
Basically, anytime you go above about 20 kW per cabinet, it's going to be more efficient to go to 480. It's going to be cheaper to go to 480. You could argue that maybe 15, but for me, that's kind of the if you're at 20, you need to start thinking about it. If you're at 30, you got to do it.
Have you been having problems when you're talking about 480 to the rack and I guess medium voltage throughout the facility? There are a lot of code issues, and for example, in the places where we have facilities, you find it very hard to get electricians willing to work on that, and the cost for build out ends up being so extravagantly high that it ends up, at least in our experience, being a lot more effective sticking with like 208 or 120 at the rack, unless you're talking about trying to earn back the cost over like a 15 or a 20-year period.
You're absolutely right. So if I were in an existing data center, something that was built, 10 or more years ago, I wouldn't think about using 480. It's just too difficult. The systems weren't designed to support it. Yes, some may come back and retrofit them and may be able to do it, but there's always issues with that. Most of the 480 you're going to see is going to be in the newer data centers, and it is the real thing. I mean, it's when you're dealing with 4160 on the high side and 480, you're talking about linemen more than you're talking about electricians. You're talking about people that have years of training, either military or working for a utility, that are comfortable and know how to work with those higher voltages. That also, we have a lot of talk about reducing reliability because sometimes in a cloud situation you don't need 2N. But when you're dealing with higher voltages, you do need concurrent maintainability, which is the ability to de-energize everything you work on without affecting your load. Again, older data centers don't have that. In general, newer ones can be designed to accommodate that. But that's really a critical thing as you go to those higher voltages, is having that concurrent maintainability.
And having the code and jurisdiction to allow you to do that cost effectively. Even new data centers like in Tampa, Florida, for example, you're not doing that because you're not allowed to work in that jurisdiction for 408 without a rubber suit.
Right.
You're not going to get people working in the data center in a rubber suit without paying them.
That's true, and most of the data centers. So this is where the web scale data centers in the middle of the country. There's a whole bunch of data centers in New Jersey that fit this profile that were originally built for financial services, but there is a whole education process behind the code, behind firefighting, behind all of the aspects that go around the data center too.
You talked about pulling dark fiber straight into the cabinets nowadays, but in most cases, OSP cable isn't plenum rated. And, pulling a 244 count over fiber trays and you have 6 carriers coming in, it's going to fill up your fiber tray really quick with OSP cable. So
it does, and those are both challenges. In some cases, if it's a short run, and depending upon what the external conditions are, so if it's in a campus situation, just pull plenum rated in the outside plant too. Mm-hmm. That's what I've seen done. If it's not, you either have to put it in conduit all the way to the cabinet, or you do have to do a fiber splice at the entry and go to plenum from the entry in. But it's still dedicated, and it does fill up your fiber trays. We've actually gone with the conduit solution in most cases, where if there's a particular core, or in many cases it's 2 cores within a data hall, we'll bring in conduit from each entry point all the way above that cabinet, and just drop down into their core network cabinet and fan out from there.
And you talked about a passive meet me room. So if a carrier was to splice their OSP into a passive meet me room and then have structured cabling back to their cabinet, could you see where the carriers would sort of balk at that because we're adding splicing points now into their dark fiber, creating more loss? That was sort of an issue that we had with a few carriers when we discussed that with them.
It's not so much the carriers as the end users balking about it, because they're trying to minimize the loss. Particularly if you're on the line between different sizes of lasers, you want to keep it down as low as possible. So that's really the justification for doing it all the way straight in. So. Any other questions for me before we switch to panel mode? Great. So I guess we should start with letting Phill Lawson-Shanks from EdgeConnex and Craig Weick from CME introduce themselves.
Good morning.
You have to press the button.
Press
Hold
the
it.
button.
Press
okay,
and
press and hold. Okay. Good morning. I'm Phill Lawson-Shanks at EdgeConnex. You've probably heard about us. A lot of you are our customers. We designed. We came at a very different space for the data center business. We decided not to build in the peering points. We feel that we created the edge mentality. We designed from the ground up specifically for the next generation of network providers and content distribution and delivery infrastructures. So these are typically smaller buildings than you'd expect from the large cornfield type data centers, but a lot of power, able to take 20 kilowatts per cabinet or above, designed really for the next generation of blades and CDN platforms. Oh no, carry on.
Hello, my name is Craig Weick with the CME Group. So CME Group is the world's largest derivatives exchange. We trade about 3 billion contracts worth about $2 quadrillion annually. And yes, I mentioned the word exchange, but we're the old school, like you throw people in a room in a pit and let them argue over the price of pork bellies or your bacon this morning. But about 90% of the transactions today are all electronic. So ergo, we have data centers, right? So basically it's an electronic pit now for futures and stock market and things like that. We have 2 data centers in the Chicago area, one large one in Aurora, 184 megawatts, primarily for financial trading. We also happen to have the first floor of the 350 East Cermax. That's probably why I'm here. I'm hosting M6 in Chicago as well. So.
Thank you. Thank you. And, you know, as we've done in past data center tracks, we want to make this as interactive as possible. So I have a few seed questions that you see up here, and I have a lot of questions in my head. So I can keep asking questions forever, but I'd really like to involve the audience as much as possible. So whenever anybody wants to ask a question, even if it's right now, just go up to the mic, and I will yield the floor. So I'm going to start with Craig in the first question, because you know you have kind of the unique role of working in a company where data centers are extremely important, but have nothing to do with what the company does from a day-to-day perspective. And you know, just kind of give us your sort of anecdotes, and no specifics, but just anecdotes on kind of how you approach the challenge of developing, explaining, communicating the data center strategy to the rest of the organization, so that you keep your job and that everybody understands what the risks and issues are that are out there.
Our data center strategy is never go down. I mean, that's kind of the fundamental way we approach. So when you talk about efficiency and reliability, reliability is always number one regardless, because we can't go down. We're open 23 and a half hours every day, 7 days a week, things like that. So number one strategy is never go down. The other dimension that's become more relevant to, I think, this audience is that the data center to us is an access node for our customers. It's just about access to our products that are trading. So from my standpoint, I only host my customers because I want to give them space to buy my products and trade and facilitate with other customers. And so that drives a lot of how we run the data center, what we provide, and how we treat our customers. And so I think there's a lot of other businesses that are like that in the enterprise space, that the data center is a choice from an infrastructure standpoint, but it's also becoming where their customers are connecting to them, which becomes important. And it becomes more important as it goes time, when customer cost gets higher and higher to access your business as well.
Thank you. So John, same question with a little different bent. You deal with both service providers, end users, all kinds of different levels of customer, but you kind of gave the vision of software-defined networking. That's very different than a lot of people are familiar with, or software-defined data center. Sorry, I made a Cisco slip there. So I'm just curious, when you go, deal with an enterprise that doesn't necessarily understand, that isn't necessarily a data center savvy group, how you sort of help them start to build that strategy and the thinking and the, appreciate those different components on that, the chart with all the blocks.
Sure. So from that perspective, one of the things that I've done in the past is it's very important to get alignment from the various groups. So typically the way you do that is that you want to take the most executive level sponsor in the organization, who is the one who is going to drive this initiative. And then you need to set up internally a workshop for those key stakeholders, because what we're trying to do is we're trying to transition the power from that executive sponsor to you as an individual trying to get this project off the ground. So basically, it comes down to having a workshop and a kickoff session to create A, the awareness. Also, B, you want folks to buy into it. And C, you want them to then contribute back to the process so that now they're actually the ones who are helping drive that as opposed to you doing it. So it's creating the awareness, getting the transition of power to you as a stakeholder in the organization, and then it's ultimately getting folks involved so that they help become part of that solution.
Thank you. And I guess, one thing I would add to that, and I think this is really important to the group here who, oftentimes are the stakeholder or are part of that team making the decisions, is it's very important early on to determine if there are any closeted stakeholders. That might be the CFO, that might be if you're a very big organization, it might be someone in purchasing. Very important to go around to all those people up front and ask them if they want a seat at the table, even though you might not want them at the table. But it's much more painful when they take that seat at the 11th hour in the middle of contract negotiations after economics are set than if you get them there up front. So I would just add that. And then
Gabe, I would just add find your attorney and your tax attorney as well. Your tax attorney is now sitting at the table determining where you're going to put your data center, as well as whoever's handling data sovereignty, where data is and where it can go. It's not just real estate and IT fighting over where the data center's at anymore. It's a whole room of people.
Yeah, no, that is definitely true. It's also true if you're working with any nonprofit organizations, a hospital, they have very different tax rules on their equipment and other components than for-profit companies. So those are important issues too. And data sovereignty is becoming huge. Huge business opportunity in the data center world in Europe too. So it's not all bad for those of us in data center world. So back to the data, how do you develop data center strategy? How do you communicate what you're doing to Phill? I mean, a lot of your customers are, well, not necessarily a lot, but some of your customers are service providers that are very cost conscious. And all of us that have been through the evolution of data center know that, when we first started doing 2N data centers, everybody wanted them, but nobody would pay anything more for 2N than they would pay for N+1. So, how do you kind of rationalize sort of your strategy that you've developed with the customers that are extremely cost conscious to bring those things together so that they feel like they're getting value?
No, that's a good question. So it starts with the location, because a lot of the data centers that are usually built, as I say, they're in the cornfields or in the center of town around the telehouses. We took the view that we wanted to enable our customers to get the lowest possible latency to their end users. So the majority of our customers are MSOs, so that requires us to build where their ag routers are, which are typically on the periphery of the metro. So we find locations that sit on a bunch of fiber or are very, very close to fiber, so we can have the dual entry, that we can provision enough power to for the day one build with enough additional power available in the grid, because the way the grid is structured, you've got to start working very, very, very much ahead of time with those distribution companies to make sure that they can actually deliver the power you need over the course of your build and your ownership of the building. And then also that it's within 10 kilometers of the ag router, so they can be passively connected. So that's that side. Then in terms of the power, obviously the power requirements of the new technologies is far greater than it has been for the last 5 years. It's just becoming more and more. So we design these with N+1 across the whole spectrum from the transformer down to the cabinets. We take the view that we need to provision enough power to enable them to go up to 20 or beyond 20 kilowatts a cabinet. Every cabinet with they don't have to buy empty space, so we provision a lot of cooling. But also the way we charge for that is very different. We don't charge a space premium. In fact, we charge no space at all. If a customer wants to put in 20 kilowatts of power, or a cabinet with 20 or 5 cabinets with 10 or whatever that works out to, we basically say it's $200 a kilowatt times the amount of power they're doing per month. We don't charge for a PUE uplift at all. We take on the burden of the cooling. We feel that's our responsibility. And we do a passive pass-through of the actual power they use. So it's a very radically different model. It enables them to forecast their cost very efficiently. And the cross connects, we do a one-time fee on the cost. There's no MRC. If all their infrastructure is within the building, if they're tethering to outside sites, then we'll give them the ability to rent a panel in the Meet Me rooms. But we're looking at it in a very different structure. A lot of power, a lot of cooling, but enabling our customers to grow and then peer locally. These are really the next level of peering points for the internet.
So if I were to draw a theme there, which I think is something important for people to take everywhere they do business, it's transparency. It's putting on the table what the deal is and making it clear to all parties, and not holding surprises for later on. So I think that's a good way to think about any provider you're dealing with is how transparent they are. And if they're not willing to be transparent, that's a big problem. So was a question?
In most of your models, do you find that your customers would rather provision their own actual bandwidth, or that they come to you for any of the bandwidth actual provisioning, or even in most cases, even thinking about the actual carriers for state for those fields?
So just to repeat for the recording, the question is, do you find that most customers want to provision their own bandwidth and select their own carriers, or that they're coming to the data center for that? I think all three of you have a perspective on that, so let's just start with John and go across.
Sure thing. So we believe in choice. So we think that we're carrier neutral. And if it's in that facility, you can choose one of those carriers.
Yeah, our facilities are carrier neutral as well. I mean, we're lucky to have about 25 carriers in Aurora, customer choice. We do have a little bit of rules around structured cable and how we provision cross connects, because we have to do equidistant and things like that because of the marketplace. But other than that, we have customers that bring in dark fiber and want to, put up their own gear, all the way up to people that are just looking for service providers.
Yeah, the same. We're carrier neutral also. So, and a lot of our customers have their preference for different carriers. So, if we're building a new site and those carriers aren't in the building or haven't started to work with them, then we work with them ahead of time to get that provisioned.
So, just to put a little context around the second question of what does the architecture for a utility model of infrastructure delivery look like? So. It's not, maybe architecture is not exactly the right word. It's kind of all of the components of data center in terms of how you've procured it, how you set it up, how it's being operated. But the end result here that we're looking for, it kind of came from a discussion I had with an enterprise customer a couple months ago when I was talking to the CTO and just kind of, he's got a lot of issues he's dealing with. And I said, what's the biggest issue you have? He's like, well, we kick off 3 or 4 new projects in the company every quarter, and they're typically lasting 6 to 18 months. And he's like, even though I've got virtualization in place and I've done things to shorten my time frame, it still takes, I can't deliver faster than 10 days. And people want, the people developing these new projects, they want Amazon delivery. They want to be able to pull out their credit card, turn something up, and be operating this afternoon in hours, not days. And I just don't know how I'm going to get my my organization to get there. So I'm going to start with John on that one, and because it does kind of fit with the whole idea of software-defined data center and the strategy that we were just talking about. But how does someone that's coming from a very traditional, federated, project at a time data center world get into that continuous production mindset of what Amazon can provide?
Yeah, I think that's a very good question, and that's a question that most organizations have to deal with at some point. And the challenge becomes, if I'm provisioning a DevOps environment and I'm spinning up resources, there really isn't a big risk for me spinning up or taking down those resources. The gap is when you are doing a production environment. So as soon as that goes to production, it's all the IT service management checks that have to come into play. So from that perspective, a lot of that additional time that needs to happen to do a specific activity really lies in that process. So from a process perspective, there's a lot of companies look at tools to be able to streamline that process flow to get those change approvals done as fast as they can. We're also seeing a lot of companies leveraging configure to suit from a co-location perspective so that they can at least configure cabinets and get up and running in a short amount of time. But really, I guess, from my perspective, it really depends on the service level agreement for that specific workload. If you've got a development environment, it can be spun up pretty quickly, and that's Amazon-ish. But when you get to the enterprise space and you have workloads in Amazon, now you have to be able to tie in all your change control processes to those Amazon workloads. So regardless of where that workload sits, the process now becomes the bottleneck.
So we don't sell to enterprise at all, so it's a slightly different challenge or answer for us. So our customers, they have a prescribed platform that they drop in. What we're seeing a lot more, though, is the MSOs that are attached to these sites, they're selling those web services to Amazon. So we're developing, or we're working with all of those cloud companies to help them provision fast access ramps to their larger clouds. And we're seeing a lot more, hybridization is going to happen. That as equipment ages in the enterprise, as data centers age, there's a decision to be made whether you want to re-up on your hardware or you just go straight to one of the large cloud providers. But not everything can be virtualized, so there's going to be a level of, there's going to be Oracle boxes out there or SunSpark or whatever that are running a key piece of technology that has to be in close proximity to a fast on-ramp to the cloud, so you can do that bursting and transitions between the two. So I think in terms of utility, I think we're going to see a lot more of that happen. Technology is becoming commoditized, which is hard for me. I spent over a decade at Compaq in the server division, so it's a very hard thing for me to say that, but that's happening. And I think realistically, we're going to see a lot more of that happen in the network world as well with NFV and SDN. So utility is going to, what we term as utility is going to change a lot over the next few years. But our view is we're working with the large caching and distribution companies to help them develop those on-ramps so as their customers and your customers to move into that world, we'll help you do that as fast and as efficiently as possible.
So just a follow-up question on that, Phill. I guess, it's one thing to do, we all know what Direct Connect is and the cloud exchanges and just getting more better controlled access to the cloud. Do you see, out there on the future, we hear people talking about, micro data centers and more kind of uniform, cloud compute capacity very near the edge, whether that's, in an edge data center or whether that's even, out on a cell site or on a pole someplace. Do you see any movement in that direction in terms of getting more actual compute and maybe even storage capacity very near the edge as opposed to just the network connection?
Yeah, absolutely. I mean, we think that we're the closest possible point to the majority of the customers in a metro right now for the larger bandwidth use. But as LT5 comes on and all of that, our business started in the cell tower business, provisioning connectivity to those towers and hut to the bottom of the tower to do almost like a mini meet me room colo at the bottom of towers. So we see a transition back to that, and not only tethering those facilities back to where the main content caches are in our buildings, but also as we move to the Internet of Things, and there's huge debates around Internet of Things and what protocols are being used and how chatty they are and how big the packets are. But realistically, you're not going to have your Nests and your smart locks communicating back to Oregon data centers. There's going to be some level of transaction processing required at the edge to do analytics or whatever. So we see that as a huge growth path. And whether they're going to be containerized mini data centers or mini caching engines or transaction coding engines sitting at the bottom of a cell tower on top of a building, I think that's all to be seen, but it's going to be there.
Yeah, and I think you brought up a really good point there, Gabe, is that, the future state is not defined for these data centers. And if we do start to see, you know, all these software and platform as a service companies building on the edge, that's a great point, right? Who's providing all of that storage that is currently in the cloud today? And so I think from your perspective, you're saying that this could be a gap that needs to be filled on the edge. That's a good point.
Yep. So we talked some, or I talked some about PUE and how it's calculated. You know, fundamentally, the challenge we have is, you know, how do we save energy in the data center, and how do we become, you know, more efficient over time from all aspects of that, from how we design it, how we operate it, whether we have renewable energy involved in the equation. You know, I guess I just ask, again, starting with John, going across, each of you to just give, you know, we're kind of coming up to the end, but each of you just to give, you know, a couple minutes on kind of what your vision of you know, how you get to higher energy usage moving forward is. Higher energy efficiency.
Sure, so I'll start with that. So I think from a higher energy perspective, I think it really is going to need to start with that strategy and making sure that all the pieces that belong are there. So you talked about having, you know, bringing in the power, but you need to have a data center that's going to support up to that 20 kilowatt. But in addition to that, it's also going to be what does our legacy hardware look like? Are we going to use legacy hardware? Do we have to go to a new hardware platform? And really making sure that we have that cohesive strategy and stakeholders are brought in so that when we do try to drive to that, there aren't any gotchas and we have alignment and can get to where we need to go.
And just to add to that, I think on the PUE question, right now it's a kind of contractual issue more than anything. I mean, if I'm going to share on the PUE, I want to share on the upside if I'm more efficient than others and how we figure that out. But broader, going back to what we talked about before, was I think the business expectations have changed and how they expect to analyze their infrastructure costs. So they're expecting that all this complexity about long-term commitments and all this other stuff to be masked behind the scenes for them, and they just want a number. They just want a number what it's going to cost and how quickly it can be done and turned up or turned down and failed. So PUE tends to get into that aspect of enterprises can't plan, they can't see 6 months out, they just can't anymore. And so the business dynamic has changed, and that's driving some of the changes on how people are doing their business models for data centers, and that's good.
Yes, as I said, we don't charge a PUE uplift at all. We take on that burden. And also, we're in the enviable position where every build is a new build, a brand new build. We buy a building, a shell, and within 3 months, or 5 months is our standard. It's a data center with traffic passing. So, and to that end, we had to think about a whole different way of managing and monitoring these systems. So we built our own DSIM from the ground up. So from a single pane of glass, our customers can either go into our site or use API calls to their own DSIM. And they can see exactly how much power is going to every single PDU in the cabinet, the return air for their components. So we expose everything to them to allow them to understand the efficiencies that they're achieving in their own cabinets. And it gives them the ability, as they're deploying blades with hypervisors or containers, they can then choose to spin things up, spin things down. They're in complete control of their destiny because they can see every aspect of the cost.
Great, thank you very much. You guys can just stay there as I finish up so we don't get into any disruption. I'm glad to, sure.
Can you explain why PUE is becoming less of an accepted power efficiency assessment?
So the question is, why is PUE becoming less of an accepted power measurement? It really comes down to there's no standard for PUE. You would think it's just as easy as stating, you know, what your total power usage is and dividing it by your critical load. But a lot of people don't do that, and particularly when you're seeing low PUEs promoted, you know, 1.1, 1.15, they might be playing with those numbers. So that's, in my presentation, why I said it's so important to understand how that calculation is. I mean, the concept of PUE is great, and it's a good starting place, but you just need to realize there's no standard out there for it, and so you have to either state exactly what you're expecting, or be able to analyze that as part of your selection process. I don't know if you guys have anything to add. Any other questions? Okay, I'm going to briefly give an update on OpenIX. So, people have asked a lot of us, what is really the value of OpenIX? Why did a bunch of people that were just sitting around NANOG talking about network issues start it? And it really comes down to these 4 points. We wanted to develop standards that focus on what people in the network world and the edge of the network need. Physical, operational, and community standards. What are community standards? That's open network, neutral access, uniform approach to carriers, so there's no favoritism. We wanted to do that in the context of a very transparent, member-supported, member-contributing organization. We wanted to have clear, accessible, and economic process. What does that mean? That means that we wanted to have certifications that were accessible. One of the fundamental issues was that everybody would say that they have a Tier 3 data center, but very few of those are actually certified. And so that really was meaningless to most of us out doing searches, because it just meant we had to do a full analysis of the data center. So we sort of on the data center side said, well, let's just boil down the few items we need, make a standard that's simple enough, easy enough, accessible enough, cheap enough, that people can go do that, certify that, and we don't all have to go analyze it before we look at that data center. If they've gone through that process, that's good enough, and we'll just pick that data center. And that's really the end goal, is to have a database of data centers and exchanges that meet those requirements, that our members can go to when they're looking at new markets and understand, not necessarily those are the only ones they can go to, but these facilities meet those requirements. So that's kind of the core value proposition of what OpenIX is trying to do. Our status right now, we have 182 members, 10 certified exchanges in 9 cities. We have 29 certified data centers and 15 companies. And that continues to grow. We have 3 additional certifications in the pipe right now. This last year was our growth into international. So we're seeing that there's, although we were kind of inspired by Europe, that most of the rest of the world was more like the US, and so there's a need for kind of the openness, the standards there. And so, we've in the last year seen AM6 in Hong Kong and Amsterdam, Milan IX, and Jaguar Networks with their data center in Marseille all join, and we've talked to a number of additional international players. Again, it extends that value proposition to the international front. We also have a number of facilities that are dual certified, and this is just a snapshot from our website. You can go to our website, anyone can, member or not. You can see the certified facilities, and you can see the ones that have dual certification, where both the data center and the exchange in that facility meet the requirements, the community developed requirements. New initiatives that we're working on are around tiered exchange standards. So the possibility that we can open it up to a broader group of exchanges. Is this idea of the micro data center or the lights out data center that doesn't have any personnel? What are the standards that go around that? In infrastructure, single corded lineup. We talked some about that at the last data center track in some of the presentations in Montreal. But really developing a standard that lays out, if we're going to scale back reliability, what are the minimum things we have to have, and how do we make that uniform? Enterprise tools, some questionnaires, some RFPs, hopefully even some model contracts that will help enterprises and even service providers procure data center space in a more efficient quicker and more uniform way, so that they can go to 3 or 4 different providers around the world without feeling any pain from doing that. That they don't feel like they have to go to a global provider, there being only 2. Education. Just as NANOG has education initiatives, OpenIX is developing education initiatives, which you'll hear more about as the year goes on, and continuing our international growth. And finally, we're always open to volunteers. We have 4 committees. We have a committee on the Exchange standard, committee on data center standard, a marketing committee, and a membership committee. And anyone that has any interest in the Exchange and data center community or helping us grow that, we'd love to have you grow. We've got a lot of new members coming into the committees right now, so we hope to really revitalize it and go into our 3rd year strong. So with that, the track is concluded, and I thank you very much for attending, and look forward to talking to all of you through the conference. Thank you.